In this video, we will be talking about the solubility rules. So, solubility rules. And well, these rules are what determine if a compound is soluble in water, if it can dissociate in a water environment. So it is very similar to what we talked about in electrolytes, how a strong electrolytes can ionize 100% and weak electrolytes partially. So it is related. So usually you won't have to learn this because they will be given to you, but sometimes they won't, and well, you will have to learn it. So that is what this video is for. So let's start with the first solubility rule. What it says is that all common compounds of group 1A cations and ammonium ions are soluble. So what this means is that things like lithium, actually let me write the rule first. So compounds of 1A is written in Roman, so that's group 1A, are and ammonium, ammonium ions are soluble, so they will be able to dissociate 100%. So what this means is that things like lithium ion or sodium, potassium, rubidium, and cesium will dissociate. And we talked about ammonium too. So and NH4 is the formula for ammonium. So whenever you see these things, if you see like sodium chloride, let's say, that has sodium, which will always dissociate in water. So this means that sodium chloride will be able to become this in your ionic equation. So when something is soluble, you will say that, let me erase this. I'll write it again for you to have it. You will write there that it is aqueous. So you write an A and a Q. So that means that it is soluble in water. It will be able to dissociate, as said, into its ions, like exactly what happens to a strong electrolyte. So let me write down really quickly what these elements were. So there you have it. That is the first solubility rule. Let's go to number 2. It says that all common nitrates, acetates, and perchlorates are soluble. So nitrate, acetate, and perchlorate are soluble. Okay. So what this means is that compounds that have NO3 minus, because it's an anion, CH3COO minus, and ClO4 minus, which is this is nitrate, this is acetate, and this is perchlorate. So if you ever see something with that, you will be able to dissociate in water. So let's say something like lead NO3, and it has a 2 because of it. So this will be aqueous because we have that nitrate there. So it will be able to dissociate into its ions. NO3 minus. That is the second rule. The third rule states that all common chlorides, bromides, and iodides are soluble except those of silver, lead, mercury, and copper. So it's saying that Cl minus and Br minus, which are chloride, ion, and bromide, are as well as iodide. So I minus iodide will be soluble except if they're forming a compound with silver, so except for those of silver, which is silver, lead, mercury, is a 2, and copper. So what this is saying is that if you have a chloride with another transition metal, like, alright, let's go with the usual one, NaCl, that will, it has that chloride, and because of the NaCl and the chloride, this will be aqueous. So that means that it will dissociate into its ions. However, if let's say you have, let me erase this part, let's write it down. You have the silver chloride, and what's going to happen is that I think it's a solid. So instead of writing aqueous, because it will not dissociate, it will remain the same pretty much. So you'll still have AgCl. It won't divide into like Ag plus and Cl minus. That won't happen because of the silver. And that's what the third rule states. Now let's go to the fourth one. So the fourth rule. This one says that all common sulfates are soluble except for those of calcium, strontium, barium, and lead. So sulfates, right with a parenthesis, so they're SO4 2 minus, that's the charge, are soluble. Probably write smaller. Except for those of so calcium, strontium, barium, and lead. Lead is, you can already say that lead doesn't really ionize at all. So what this is saying is that usually sulfates, so let's say something with this, will be aqueous. It will be able to separate into its ions. So this will be 2. However, if this X is equal to, like, let's say calcium, so calcium SO4, they're both 2, so you don't write anything. It will not be aqueous. It will not be aqueous. So it will probably be solid or liquid. I think it's a solid, and you will have it. It'll remain the same. It'll remain the same. It won't, as I said before, it won't ionize into its ions, into its parts. So this won't happen again. That is the fourth rule. Now, the fifth rule. So there are 3 more rules for a total of 7. But from now on, from the fifth rule, there will be what is insoluble instead of what is soluble before. Like you'll see. So this one says all common metal hydroxides, so OH minus is hydroxide, are insoluble. So instead of saying like before soluble, this time they're insoluble. Let me fix that. Insoluble. except those of group 1A and the lower members of 2A, starting with calcium. So, except 1A and lower 2A. Well, and we know that 1A are the elements that are most of the time soluble, like lithium, sodium, potassium, and it goes on. Well, so this is technical, the first rule. So this cannot be insoluble. So that is why they are the exception. So like the rules kind of they overlap. So, and the lower ones of 2A, it will be from calcium, so it will be calcium plus strontium, barium, and radium. So just to give you an example, silver hydroxide, silver OH, will not be aqueous, so it'll be solid or a liquid, I'm not sure. So it'll be the same. However, if you had calcium hydroxide, it would separate into its parts. Now let's go to the sixth rule. All common carbonates, so CO3 2 minus, and phosphates, PO4 3 minus, are insoluble. Soluble, okay? Except for those of group 1A. So again, as I said before, in the first, like what the first rule says, except 1A, sodium and lithium will always be soluble when you have them. So these will be our exceptions, and NH4 plus, which is ammonium. So lithium carbonate will be aqueous because it is one of the exceptions. It will be La plus here, and CO3 2 minus. You put a 2 here just to balance it. So you can figure out that it can ionize if it's one of the exceptions. Finally, let's go to the seventh and last rule. So 7. It says that all common sulfides are written as this, so they're salts, are insoluble except for those of, you can figure it out now, except for those of 1A, 2A, and well, ammonium. So again, it's the same, it's the rule number 1 over and over, being the exception for solubility. And well, those are the 7 solubility rules. I would say that the best way to learn them is by practice. Just write them in an index card and look at them many times, memorization, and then just solve problems. Figure out if something like this will be aqueous or not. And just keep doing them. Just keep adding your elements to form compounds, and just figure out if they're soluble or not. And that will be the best way for you to study for the solubility rules questions or problems. And well, those are the 7 rules.